Let us look at question 4. I've jumped question 3 and question 2 and 3 because there are some concepts which we need first to know from question 4 for us to solve question 2 and 3. Okay? So the question is, a particle moves along the x-axis according to the equation x is equal to 2 plus 3t minus 1.0 times t squared, where x is in meters and t is in second, at t is equal to 3 seconds. Believe me, whether you like it or not, a question similar to this you are going to see it in either test 1 or in your exam. These are one of the most interesting questions under linear motion. So now, allow me first to explain and then we'll come back and solve these questions. When we are talking about the position, when you hear the word position, we are talking about the distance. We are finding the distance. So the position has been given, the particle has been given x is equal to 2.00 plus 3.00t minus 1.00t squared. One thing I want you to understand is that when I want to find the displacement is the value of x. That's why we have been told that x, where x is in meters, we want to find when t is equal to 3, what will be x? That is the displacement. So x is the displacement. Get me right there. Now, if I differentiate this thing, if I take you back to calculus, if I differentiate this thing, the formula when I find that one is going to be the formula for the velocity. If I differentiate the formula for velocity, it's going to be the formula for the acceleration. That's how it works. That's why they always ask you to find the position of the particle, the velocity, and the acceleration. What do I mean? This is the equation which I have, but I know that this one I can write it to be the same as negative 1 point or negative 1. Let me do this. It's the same as 2 plus 3t then minus 1t is the same as just t squared. Okay, so let's differentiate this. How do we differentiate a function? If I've got a function f of x to be equal to x squared, to differentiate this or to find the dy over dx, you drop the power reduces by 1, which is going to be 2x. What if I've got 2x squared? You drop the power, is going to be 4x. What if I've got 10? The derivative of any constant number is 0. So in this case, this one is going to be 0. Does that make sense? Now, let's try to differentiate this one. So if I find dx over dt, I'm differentiating with respect to t because I'm talking about t, which is the time. The derivative of 2 is 0. The derivative of 3t is 3. The derivative of t squared, you drop the power, is going to be 2t, like that. Then the final one will be, meaning now the formula for the velocity with respect to time is going to be 3 minus t, 2t. That's the formula I'm going to use. If I differentiate this, I'm going to find the formula for the acceleration. So I will do the same. So in this case now, I'm talking about, it's no longer x, I'm talking about dv over dt. So dv over dt, the derivative of 3 is 0. The derivative of 2t is 2. Okay? Meaning, my acceleration at that point is going to be equal to negative 2. Now, I'll go ahead and find the answers now. Okay? I'll go ahead and find the answers. So the same formula which we have been given, I'll just plug in the values. And then I'll go ahead and find the answer. The answers, as simple as that. So can we go ahead and find the answers. Okay, so what we are going to have now is the first one is when t is equal to 3. I'm going to use the one for the position is the same one, so it's 2 plus 3. Now t is 3, then minus t is again 3, but we square it. I'll end up having 2 plus 9 minus 9. This and that will give me 0, and I'll end up having 2 meters. Does that make sense? Then if I go to the other one, what are we going to find? Let's see. For the velocity, it's going to be v as a function of t. Now t is 3. 3 minus 2, open brackets, 3. So v as a function of 3 is 3 minus 6, which is negative 3 meters per second. Any question? Okay. So what is the answer for the last one? The same what? What will be the answer for the second one? Oh, the acceleration, sorry. Negative 2 meters. Yes. That's all. So I don't think this is, so the acceleration as a function of 3 is negative 2 meters per second squared. As simple as that. I hope this is going to help us now to go to question. I think I'll first go to question. I'll first go to question 3 before going to question 4. So let's talk about question 3, which is talking about it's basically the same concept from question 4. That's why I had to start with question 4 before coming to question 3. So question 4 or 3 is saying an object moves along x-axis according to the equation, which is x of t is equal to 3t squared minus 2t plus 3, where x is in meters. We know already is the distance. So determine part A, the average speed between t is equal to 2 seconds and t is equal to 3 seconds. Now, in this case, when we want to find the average speed, we have got 2 times. So it's more like you have got t1 to be equal to 2 and t2 to be equal to 3 seconds. Okay. So what is happening now is I'm trying to find the average speed. We do know that the average speed is given by the average, or let me say the change in x, which is the displacement, times the change in t. So the change in t is basically t2 minus t1. Okay, it's difference here, and there's a difference where question 4, if you remember very well, it was just saying find the speed, not the average. Okay, because when we're talking about the average, meaning we have got 2 points at that point. So what I need to find is what is the displacement when t was equal to 2 and what was their displacement when t was equal to 3. I hope it's making sense there, so that I should come and say the change in x will be equal to the x2 minus x1. So the x2 is going to be when time is equal to 3. The x1 is going to be equal to the time when it's equal to 2. So it's something that is, it's not really difficult to do it. Okay, So when t is equal to 2, we need first to find the displacement. What did I say about finding the displacement? The previous question. Okay, just a minute before you even contribute something. Like I said, so here we are using displacement, meaning what should come in your mind is that this one we are talking about the distance. So in short, we are trying to find the average. We need first to find the distance. Okay. So how can we find the distance? So first of all, when we're talking about the distance, now I have to change because I was thinking maybe this is the velocity, but it's a speed. So you remember last time we say I was talking about when we're talking about the distance, we are not focusing on the direction. If you can remember very well, okay? Yes, we are just going direct to um, we are just going direct to the. But anyway, we're still going to use the same one. But I just wanted to emphasize on the difference between the speed and the distance. So in this case, or the speed and the velocity, since they are talking about the speed, then us we're also going to be talking about the distance. So what I'm going to do is it's the same formula. So I'll say when I'll start with when t is equal to 2. When t is equal to 2, then it's going to be 3 times 2 now squared minus 2 times 2 plus 3, which is going to be 12 minus 4 plus 3. This is going to give me 1, negative 1. Then what are we going to have there? The distance of what? 11, right? So when t is equal to 2, the distance is 11. What of when t is equal to 3? So it will be 3 times 3 squared minus 2, 3 plus 3. It will be 3, that squared is going to be 9. 9 times 3 is 27 minus 6 plus 3. So this guy and this guy, they'll give me negative 3. Then 27 minus 3. What is 27 minus 3? 24. Okay, so I have 24 meters. Meaning that now to find this distance, one thing we should know is that we have got so I've got x2 to be 24 and x1 to be 11. So I'll have the change in x will be equal to x2 minus x1, which is going to be 24 minus 11. What is 24 minus 11? 13 meters. So 13 meters is the distance I'm going to use. So I'm going to say the average. Now it's the average. Sorry. So this formula I'm not supposed to say the average velocity. It's the average speed. It's the average speed. So it's going to be 13 divided by. So now here to find the change in t, like we said, is going to be 3 minus 2, which is 1. So I'll end up having 13 meters per second to be my average speed. Now, when we're talking about average, they'll always give you 2 points. You can't use 1 point. That's why we're using change in t and change in x. Okay? Does that make sense? Yeah. So now, when we want to find instantaneous speed at t is equal to 2 and when t is equal to 3, what are we going to say? Now, Instantaneous, like you have said, it's basically the same thing. Instantaneous is the velocity at that point. So we can't start saying t1 minus t2. No. What is the velocity at t is equal to 2? That's all. That is instantaneous speed. What is the velocity, or what is the speed at t is equal to 3? We're not talking about the average. So we're not going to be doing minus. So what is the velocity at that point? What is the speed at that particular point? That is instantaneous. So here what we're going to do is, when we're talking about instantaneous, we're going to be finding the velocity at that point. So what is the velocity when t is equal to 2? And what is the velocity at t when t is equal to 3? So to find the velocity, remember I said you differentiate this function. The function is this. If I differentiate this function, dx over dt is going to be, you drop the power, is going to be 6t minus 2. So at t is equal to 2, the velocity as a function of time, I'll still use the same formula. Then I'll just plug in when t is 2. So it's going to be like this. 12 minus 2 is 10, right? It's 10. So the instantaneous velocity when t was equal to 2, it is 10 meters per second. I'll go back. When the t is equal to 3, I'll use the same formula. I'll put 3. Then it's going to be 18 minus 2. When t is equal to, when t was 3, then the velocity now is going to be 16 meters per second. That is the speed. So at that point, what was the speed? 16 meters per second. As simple as that. So instantaneous, we're just talking about at that point. That's all. You are done. Average, that's when now you start now doing this minus that. Okay? So you say that minus that. Simple. Now let me just explain again one thing. We were talking about the what average speed did we find? Okay, the average speed we found. Okay, it's fine. It's fine. I wanted to. Okay, it's fine. It's fine. It's fine. It's fine. Now, when we want to find this, the acceleration, the average acceleration, it's the same thing. We need first to find two things. Okay, but you know that when I want to find the formula for acceleration, it's going to be dv over dx or dt is equal to, I differentiate this one, is going to be 6. Okay, it's going to be 6. Then the question is, we want to find the average acceleration. We are going to use the same method we were using. Okay, so first I need first to find what is the average speed. I know that acceleration or average acceleration is given by v final minus v initial divided by time. So the time is the same as t final minus t initial. So I'll do the same. I need first to find the velocity when t is equal to 2 and the velocity when t was equal to 1 or to 3. So I'll do the same. Now, to find the velocity, I'm going to use the formula, this one, the one I differentiated. So I'll say v when t was equal to, but we found this one already, right? If I can remember, we found 6 when t was equal to what? When t was equal to 2, we found what? That is oh no, it's different now. Since we are using this formula, that time we are using direct, we didn't differentiate. So now we are using 6t minus 2. So when t is equal to 2, it's going to be what? 12 minus. Oh yeah, it's the same thing, right? It's the same thing when t is equal to 2. And when t is equal to 3, we found what? 16, eh? Yeah. we found 16, meaning my final velocity is 16, my initial v is 10. Now let's go to time. Again, time we already know, so it will be like this. My average acceleration will be equal to 16, which is the final, minus 10 divided by 3 minus 2. And I'll end up having 16 minus 10, 6, right? So the acceleration, the average acceleration is 6 meters per second squared. Simple as that. That is the same now. What will be the instantaneous? So it's the same thing, right? So okay, here now it's going to be interesting. After we differentiated, we say dv over dA, there's dv over dt. We found 6. So when t is equal to 2 and when t is equal to 3, what will be the answers? After differentiating the formula, we have found this 6 just. It's the same as that question when we had the constant only. So the instantaneous velocity when t, sorry, yes, it's just 6. So what will be the conclusion? Okay, so when t is equal to 2, the instantaneous acceleration is 6 meters per second squared. When t is equal to, at any point, at any given time, the acceleration will be the same because you just have the constant. It's the same as question 4. You remember after we differentiated? Yeah, it's the same thing. Okay, in this tutorial we are going to solve this question, which is saying a track covers 40 meters in 8.50 seconds while uniformly slowing down to a final velocity of 2.08 meters per second. Part A, find the track's original speed, which is the initial speed. Then part B is saying find its acceleration. Okay, so now, first, before you solve any question for physics, the first thing to do is to come up with data. So as you can see, I've come up with data. I have the displacement, which is, you can say d or x or s is okay. That is the displacement. Okay, so our displacement is 40 meters per 40 meters. The time is 8.50 seconds. Then we have the final velocity as 2.80 meters per second, but we don't know the initial velocity. We also don't know the acceleration. So as you can see, I've put question mark on acceleration and the initial velocity. Now we have got main equations which we need to be familiar with. Okay, now if you know these formulas, then you are safe. So the first formula which you need to be familiar with is to find the average velocity is going to be equal to the initial speed plus the final speed divided by what? 2. The second equation is, if you want to find the final velocity and you have the initial velocity, you also have the acceleration, you also have the time. This is the equation which we can use. The third one is if we know the displacement, we can say d, then we want to find the displacement, we know the initial velocity times the time plus half a t squared. That is the third equation. The fourth equation is the v final squared has to be equal to the v initial squared plus 2a d. So these are the formulas which we need to know. Okay, don't worry, we're not interested on how we can drive them, but we want just to see how we can apply them. Now in this case, we want to find the initial velocity. Okay, so remember, we do have the time. We're going to get the equation which has got time. Okay, but we want to find the initial velocity. So what we are going to do at first, we are going to use this equation. Okay, we know that we don't have time there. Okay, but we have the initial velocity, and we want to find the initial velocity, and we want to find the displacement. Again, we can also use this formula. Okay, so now those are the two formulas which we are going to use. So what we are going to do is, first we are going to come and we are going to say the final velocity is going to be equal to the initial velocity plus the acceleration times t. We have the final velocity, which is 2, so I'm going to put 2.80 has to be equal to, what is the initial velocity? We don't know. Plus, what is the acceleration? We don't know. What is the time? 8.50. Okay, so this is the same as 2.80 has to be equal to v initial plus 8.5 times a. Okay, so let's call this one as equation 1. Now we can just put this one here. We say we have 2.8 has to be equal to the v initial plus 8.5 times a. So this is our equation 1. Now let's get rid of this. Okay, let's get rid of this. Now we want, again, we, as you can see here, we don't know the initial velocity, we also don't know the acceleration. So as long as you have got equation where you have two variables which you don't know, we are supposed to use two equations. So we are supposed to get another equation which is going to help us to find the initial velocity. Okay, so which other equation can we use apart from this one which we have already used? We can use this equation. We can say that d is equal to v initial times time plus half at squared. Okay, so now we know the displacement already is what is 40, so I'm going to put 40 here, has to be equal to the initial. I don't know, the time I know is 8.5, then plus half the acceleration. I don't know, the time I know is 8.5 squared. Okay, so then I'm going to have 40 has to be equal to, this one is going to be 8.5 v initial plus, if I do 8.5, I square it, then divide 2, which is the same as times 0.5. Okay, which is 36.125. Or we can just say, anyway, it's just okay. Then we have acceleration there. Okay, so now we can say that this is our equation 2. Okay, so now if that is our equation 2, we also don't know the initial velocity. We have two unknown variables, like we don't have the initial velocity, we don't have the acceleration. So now we have two equations. We can choose. We can make acceleration a subject of formula, like the first equation. Or let me just do this. Let's just create space. Okay, and then let's relight this one here. We are saying that this is going to give us, it is 40 has to be equal to 8.5 v initial plus 36.125 times acceleration. Okay, so this is the first equation. Now that first equation, we're going to get it and solve for a. We make a a subject of formula, so we're going to say that the equation is 2.8 has to be equal to v initial and then plus 8.5 times acceleration. So we can shift the v initial to the other side. It's going to be 2.8 minus v initial. I've just shifted this one to the left hand side, then it is positive. It has gone to the left hand side, it's going to be negative. So this one has going to be equal to 8.5. Let me write that, 0.5 times a. Okay, so before we continue, if you want to access more videos and more tutorials, remember we solve tutorial sheet, we solve the past papers, also conduct tuitions at Transcendent Institute. Just register with Transcendent Institute and you are going to enjoy our services. Okay, so now let's continue. We want to make a as subject of formula. Okay, so I'm going to divide both sides by 8.5. Even here I'm going to divide both sides by 8.5. Okay, so now I'm going to have my acceleration is going to be equal to 2.8 minus v initial. We divide everything by 8.5, meaning that in the second equation, this is the second equation, where there is acceleration, we are supposed to put 2.8 minus v initial divided by 8.5. Okay, cool. Let's just get rid of this data. Okay, So now we're saying acceleration is going to be equal to 2.8 minus v initial. We divide everything by 8.5. Okay, so now we want, I can just get rid of this. We're going to use the second equation. Okay, so the second equation is 40 has to be equal to 8.5 times v initial plus 36.125 times acceleration. So where there is a, we are going to replace this equation. Okay, so now maybe you don't know how you can join Transcendent Institute. Okay, so if you want to register with Transcendent Institute, just WhatsApp this number 0767 729927. So just WhatsApp this number, then you'll be able to get the link, or if you want, you can just go on our website, which is www.transcendentinstitute.com. Then you'll be able to make payment using the same website. If you don't know how to make payment using the website, you can just call or WhatsApp that number, which is there. Now let's continue. We want to replace where there's a, we replace with 2.8 minus v initial over 8.5. So what we are going to do now is I can just get rid of this. Okay, so we are going to say that is 40 has to be equal to 8.5 v initial plus 36.225, and then where there is a, we are going to put now 2.8 minus v initial, everything divided by 8.5. So now what I'm going to do now is I'm going to divide this 36.125 with what 8, so that I eliminate what the bottom part. So I'm going to have 40 is equal to 8.5 v initial plus, I'm going to say the 6.125 divided by what 8.5. Okay, so that one is giving me 4.25. okay, open brackets, we have 2.8 minus v initial. So now what I'm going to do, I'm going to distribute 4.25 everywhere inside there. So I'm going to have 40 has to be equal to 8.5 v initial plus, so I'm going to say 4.25 times 2.8. okay, I'm getting 11.9 minus 4.25 v initial. I can shift 11.9 to the other side, which is going to be 40 minus 11.9 has to be equal to 8.5 v initial minus 4.25 v initial. Okay, so now we have that one, we have 40 minus 11.9. okay, so 30 minus 11.40 minus 11.9, I'm getting 28.1 has to be equal to what of 8.5 minus 4.25. I'm getting the same one, 4.25 v initial. Let's divide both sides by 4.25. Let's divide both sides by 4.25. okay, cool. Now after doing that, we need these, they are going to cancel, then we are going to remain with v initial is going to be equal to, we're going to have 28.1 divided by what 4.25. okay, so I'm getting my initial velocity as 6 point, I'm getting 6.61 meters per second. So that is my initial velocity. That is part A. Now part B is saying find its acceleration. Remember, we have come up with this formula already. This is our formula, guys. So now that formula, what we are going to do is we know that we don't have the initial velocity there, but we have found the initial velocity already. So what we are going to do is we need to understand this before we calculate. It was decelerating, it was coming to rest actually, meaning that the acceleration is going to carry a negative, meaning it was decelerating. okay, so we're going to have the acceleration is going to be equal to 2.8 minus v initial divided by what 6.61. so where there is initial here, we are going to plug in that value. okay, so we're going to say that acceleration is going to be equal to 2.8 minus 6.61. We divide everything by sorry, here is down here is 8.5. 8.5, yeah. So we're going to divide 8.5. So we're going to say acceleration is going to be equal to, so what is 2.8 minus 6.6 minus 6.61? I'm getting negative 3.81. Divide this one by what? 8.5. Okay, so I'm getting my acceleration as negative 0.4 is 448, but we can just say 4.5. Okay, it's 4.5, not 4.8. 4.5 meters per second squared. So that is the acceleration. Okay, so this is how we can solve this question. But now, if you want to access more questions with proper explanation, just register with Transcendent Institute and you're going to access all the videos. Remember, we also offer good services, tuitions at affordable prices. Just WhatsApp that number, then you'll be able to access everything. Thank you.